Okay, so for the question number 2, so the air enter an adiabatic nozzle steadily at 400 kilopascal. So this is nozzle, adiabatic nozzle. So enter at 400 kilopascal, so V1 is 400, 200 degrees Celsius, so T1 is 200 degrees Celsius, V1 is 50 meter per second, A1 is what? The inlet area nozzle is 100 centimeter square, so 100 centimeter square equivalent to 0.0100 meter square. Okay, so and leave at 200 kilopascal, so P2 is 200 kilopascal and 200 meter per second, so V2 is 200 meter per second. So remember that V without the hat here is volume, so with the hat, so I distinguish it, this one is as speed. Okay, so remember before this we have V is for volume, so V with the hat is speed. Okay, that's why in equation later on, so this one is V with a hat. Okay, so this one is the speed, right? So because there is an inlet and outlet, so the mass flow rate throughout the nozzle, because there is one inlet, so an outlet, so it's become steady state flow system, right? So the question asks you the mass flow rate, the exit temperature. What is T2 here? Because T1 you already know, so they ask you to calculate T2. Okay, the mass flow rate, so the mass flow rate here, what is going through this system, the nozzle, and then the exit area, what is A2? So because the A1 is already given by the question. These are simple kind of explanation for question in final exam, right? So they will ask you what if the amount they give here, so they will ask you what is the inlet. So if they give the amount of inlet, then they will ask what is the temperature at the outlet. So it's just vice versa. So because there is one way in and one way out, so that's mean the M1 dot, okay, this one is M1 dot, and the one that exit is M2 dot, is equivalent to the M dot. So the M dot inside here is equivalent to all the inside, in and out. So that's mean, so later on it will be easier when we will solve this equation, right? So using the ideal gas equation, because this is what? Air. Air is what? Air is ideal gas. So because it is ideal gas, then you do not have to refer to the thermodynamic steam table. So you can just simply use the ideal gas relation, which is PV equals to MRT, right? So V1 equals to RT1 over P1. Okay, so now because this is small v, so RT1 per P1. So we don't you don't need the amount of M, because this PV equals to RT. So right. So R 0.287 273 plus 200 divided by 400. Because R is what? R the given in question. So normally the question will be given in the exam is 0.2 kilo per K. That's why 273 plus 200 to get the amount of K Kelvin divided by 400 is P1, so 0.3394 meter cube. Okay, so to calculate, this is the formula for this flow rate. So this one is normally you can find it in exam in the appendix section. So okay, so 1 per V1 A1 V1. So V1 is what? 0.3394, which is being calculated previously, times A1 is 100 centimeter squared. You have to convert to meter squared, so 0.0100 meter squared. Always use the SI unit. Okay, and then V1 with the hat. So this is speed 50 meter per second. You got double 1.47 kilogram per second. So the first question we have answered, the mass flow rate through the nozzle is 1.47 kilogram per second. Okay, let's move on to the next question. So calculate the exit temperature of the air. So because energy in minus energy out is the total energy of the system, is equivalent to 0, then E in minus equivalent to E out. You might be wondering, how does we get this equation? Okay, so previously when we learned in the lecture notes, okay, so if we refer back to the theory, okay, so E in is what? E in is this one, QW. This is standard thermodynamic system, so from the first law. Okay, so anything in equivalent to anything out. Okay, this is based on the energy balance equation. Anything that's go in is equivalent to anything that out. So E in minus E out equivalent to 0. So that's mean E in equivalent to E out. Okay. So you have QW plus EMS in, Q plus W plus EMS out. If there is no effect of work and heat, then this one is cancelled. So same as this one is cancelled. The only thing is what? These two, M, H, B, G, Z. So because this question does not have effect of gravitational effect, so there is no this one and there is no this one. Okay, so this one no, this one no. So there's something just this here and this here. So instead of inlet in, we could add 1. So M1 dot H1, M2 dot H2, and half of it V2 V. Instead of E, we could 2 had here. Okay, so that's why the equation will remain just this. Okay, these two. Okay, to this one. Okay, so only this equation. Okay, this one also hold. Okay, because of that. Okay, so it's leave to M1H1 and M1H1 M1 and half V1 squared and 2H2 and half M2 V2 squared. This one is kinetic energy. Okay, so because M1 dot equals to M2 dot because M dot, so there is only one inlet. So if there are two inlet, then M dot cannot be the same as M1 and M2 because there are two inlet. This one is one in, one out. So the mass flow rate are the same. So that's why we can move out the M. So leave these two equations, rearrange the equation because the M is abolished. So H2 minus 1 and half V2 minus squared. So, and then because this is what we call as this idle gas. Okay, so remember that when we learn idle gas, okay, H2 minus H1, because this one is normally we have a steam table. So because this one has so Cp over T2 minus T1. So we can just temperature exit minus temperature inlet time specific enthalpy. Okay, so that's why we use instead of H2 minus H1 Cp T2 minus T1 and a half 200 meter squared minus the outlet minus meter squared divided by 1000. Why? Because we need, because on the side Cp is what? Cp is kilojoule. Kilo here, this 10 power of 3. That's why we divide by 1000 here. So that this one is K. This one is also the value of K. So that then we can balance the equation. Okay. So 1.02 T2 minus 200 plus 18.75. So T2 equals to 101.6 degree Celsius. So what are the exit area of the nozzle? So again we use the same technique that we use in the section 1. So V2 RT2 over P2. So we got this value and then use the same equation M dot 1 over V2 A2 V2. So we can calculate the A2 because we already know what is M dot, because M2 dot equivalent to M dot. Okay, so put M2 there. Supposedly we have to put here an M2. Okay, so then rearrange the equation, solve the equation, so you got 0.048 meter squared. So now I think we have solved the question number